Alright, well in this video I'm going to tear into the Soliton controller that used to be in the BMW, but then I tore out to put into silent to try to get that running for the land speed racing. And of course in the process of doing that I blew up that controller. So I'm gonna dig into the Soliton, see if there's any chance of fixing it, so that way I can get yet one more of my electric vehicles running, since it'd be nice to have that average more than 50% of them running, but I haven't been batting that average in, well, forever. So anyway, let's go dig into it, see what we can find. Alright, what we have here is the Soliton 1, old Evnetics box that I was racing at the Colorado Mile back in 2018, and let the smoke out. You can see that's not a good sign. Anyway, so I'm going to tear it open and find out what went wrong. The soot here is not from these terminals. It actually came out from the gap here. I'm pretty sure this is a big plate down the bottom here. Actually, I'm not sure about that, because actually I guess the capacitors would be in here and that the IGBTs would be against this nice big heat sink there. So let's tear open and see what is inside there. Have to be really careful with this because you can still have capacitors with a large amount of voltage in. Woo!
We fried something.
Look at that.
Oh wow.
So right
that's magnetic dust.
There.
That's magnetic.
No, that's the insulation.
Oh.
So there's some bus plate going across here, and it arced. I don't know if you can see that on there, but arced right across there. That's what let the smoke out. Interesting. It's actually a RJ45 in here. So that is interesting. Let's see. I'm guessing that's the IGBT driver board. Just checking everything. Okay. So no, the capacitors aren't here. This is a really big bus plate back here. Oh no. I think I voided the warranty. So battery side, motor side. The arc over happened at the battery side, interestingly enough. Now, that doesn't mean that that's the only thing that went wrong. Oh, that's interesting. So we have this connection here, which was to that and that and that. So this was measuring the input voltage, I guess. Where did that go to? Oh, no, this was in the RJ45. This...
We're looking for something like those.
Yeah, I was looking for 2 pins sticking out. Aha, right there. So this was right here. Unplug this guy. Part of the reason why I do all this stuff on cameras, and then I can go back and watch where everything went. This is actually secured from the other side, so I think I need to do is take this board off here and we'll pull it out. But I really think that actually if I take these bolts off here, maybe I can get this whole thing to come out of the assembly. Biggest thing, I don't know if this board is any good anymore. This is the controller main board. This is Rev 3.0. Thank you, guy.
You're welcome.
Ooh. That guy fried, it's fried there as well. At least it looks like it.
Oh wow. I think it launched something.
Oh yeah.
I think it blasted it.
It actually made a crater in that. I think it was just a plasma ball that formed there and eroded that away. This lines up right with that spot there. Doesn't seem like there's any sign of arcing to the plate itself. It's just eroded. Thanks, guy. That's still rigidly bolted down. Not on this end. Okay. Oh, these are the contactors. It's all covered in soot, but there are two, look like gigavac contactors inside. So this is for measuring the battery voltage, and this is used for the pre-charge, would be my guess. But yeah, the contactors are over here. So it actually arced across the contactors, that's odd. But we're still figure out where we're rigidly attached here.
Do you think these bolts?
That's what I'm thinking.
Go straight down.
Yeah, I think the same thing. What do you think? What size do you think that is?
9/16.
7/16. These. This is the current sensor over here. That's why this guy splits out into two pieces so they can fit the current sensor through on the. Oh, it's on the negative side. Interesting. Probably just where they had space for it. It's just odd that. So I had two failures on this. One, it kicked out, and then the next time when I went to diagnose it, of course you have to turn it on to diagnose it, then that's when the smoke got let out. This was hours later, and it just arced across there, and that's where all the smoke came from. I think I have to get these two bolts off here, but it's odd. These are just plastic standoffs. That's not what's holding the board down. At least I hope that's not what's holding the board down. So what? Is it just double-sided tape down? Felt more rigid than that. Oh no, it was just the plastic standoffs holding it down. Interesting. all four of these are same size screws. There we go. Those are the last two fold-outs. So this is the these are the two IGBTs for driving it, and so this is actually what drives to that. The rest of this is just the connections to the to the taps on the outside. The connections on the outside. Contactors we have here are Tyco's, Tyco Kilovacs. Well, these are only EV200s. And I'm guessing those clips there, and then I can pop that off. That plate is now loose in there, so this is the output side. We got what is connecting. I think those are just. Yeah, I think those are just blade terminals into the IGBTs. They are. There we are. Guessing I got a little wire back here. Guessing that's the thermocouple reading. Someone really crimped down on those cables. So I think the high current side is all still happy. Okay, pull these out so you can get a good view of that. So the power comes through the positive through these, gets sandwiched down. That's what these bolts were for. Get sandwiched from this copper plate. You can't see the copper plate. Put it back. So this bolt goes through here. And it comes from this big old copper plate. And then goes through that bolt down through these brass connectors, which then goes into there. So that's your current carrying path, because you don't want to carry current through bolts, at least not through the threads. You want to do it via contact, which is what they did, at least for that side. So I got a perfectly good set of IGBTs and a IGTV board for a Soliton. Now the question is, what went wrong over here? 500 microfarad capacitor. This is what takes all that ripple out of the DC and helps absorb the voltage spikes. 600 volt DC, so it's got a good margin onto it. So this is a dual layer copper board with a insulator in between. Get that camera. So there's a plastic insulator sandwiching the two copper plates. That's an SBE 700D 349, of course. I mean, doesn't everyone have one of those? Let's find out. Do we still have a good capacitor? 512 microfarads. That is a good capacitor too. So driver-wise, it's all good. The main controller board went out. I'm gonna actually clean this up and see if I see anything. I'll get the electrical cleaner out and see what comes up. But that loose wire, wherever it went, I'll look back in the video, I think actually came off of here. That would be my guess. I don't know where it went, so anyway, I'm going to take this in, get it cleaned up, see what happens. The rest of this is a really nice CNC aluminum machine case. I mean, the amount of money they spent machining this guy here, I don't know, if I were to guess, it was probably 500 bucks, 300 bucks, somewhere around there. They sunk a lot of money into this. Nice looking piece though. And not to mention that there are cooling ports that run through here. So that's what these are. So this is all one machined piece of out of a block, a giant billet of aluminum. That part of the hardware design, to give them big credit for. It's, well, at least very cool, impressive, good heat sink, good cooling. They did not skimp on that. It's also very expensive. Ooh. Yeah, got shrapnel coming out. So I think with all, actually, it's surprised the cooling isn't as intensive as I thought. I thought there'd actually be a chill plate or something like that, a path coming through here. All they did was they bored 2 holes. I don't know if they went all the way through or they just blinded it. But then on this side, put on the camera, you can see these plastic plugs here. Oh, it's backwards. There are 4 of those. So then they bored through here. You can see that very well, but they bored through there, and so so then they've got, and those bore holes over top the IGBTs, so that coolant comes through, and I'm pretty sure, I guess they have some combination of it flowing through. It would, down on the camera here, it would come in this side. I guess it would flow through here, then go through that channel, then go through this channel, go back to the first borehole, go through that channel, back to the second borehole. You need an odd number to make a return trip. So I guess it just fills this, and then that coolant will flow across, and then it returns back. I guess that's fine. Doesn't give the most even cooling, but it's also interesting there are some extra holes here. Are those for the fan or are those a design change? I'm gonna go with design change. So there are extra holes right there underneath these IGBTs, and let's take a look. Gone this far, might as well go all the way. I think these are 600 amp rated IGBTs. Can't remember the exact details. So a thermal paste on there. Yeah. Pretty sure. And back in the day, these were kind of the it for IGBTs. When you talk about back in the day, it wasn't that long ago. You guys doing building EVs these days don't know how much easier you have it with a wide selection of materials and batteries and components that back in the day you couldn't even get the manufacturer to talk to you. So, all right, well, I am going to now, that's pretty much it. It's just a nice block of aluminum with some terminals on it. But I'm going to clean that off, see if what I can see with that. Like I said, Evnetics is no longer around, sadly. Lesson for you: when people say that it's, you know, when you work on EVs, you never get your hands dirty. Well, I mean, it's not replacing the main seal on a 200,000 mile old Chevy, but yeah. So I'm gonna take cleaner here, take this board, see what it looks like underneath. I'm gonna stick by my very original theory that something happened to the terminals here, because there was that was that loose wire that we saw, and these pins were completely gone. So I'm wondering if the wire failed here. So this is a high voltage area, as it's nicely marked, and that caused an arc over that then led to the demise. Now the flip side is, I don't see any damage to the board. I actually wonder, the current arc over was just between the bus plates. So, I mean, I can clean that up and use it. Maybe put a layer of Gliptol so that doesn't happen again. But whatever. Anyway, that is the dissection of the Evnetics Soliton 1. Alright, well, that pretty much wraps it up. Got the Soliton completely torn down. Do some more debugging on the main control board here. I think actually it might still be okay. I'll play around with it later, just see if I can send 12 volt to it and get it to work. Past that, since Evnetics is around, I'm not going to really be able to find another main control board, and so we'll see what I actually do with it. But I hope it was informative and I wouldn't say entertaining, but hope you guys liked it. Give a like if you did. Subscribe. The next video, which I just need to do the editing for, is actually helping out old friend tear up some Model 3 battery modules to go into their potential electric vehicle or electric airplane project. But you guys have to stay tuned for that video. Hope you guys enjoyed it.